Hi, everyone. Welcome to a new episode of The Lowdown by Analysis.Tech. I'm going to be your host today. I'm John Rymer, one of the principals at Analysis.Tech, and I am joined today by my colleague, partner in crime, fellow baseball music fan, yada, 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 Rick Greenwald. Rick, I wore one of my Hawaiian shirts in your honor today.
John, that's too big for you, isn't it?
Well, I wear it when I drink beer because I need a little extra space. So anyway, Rick, welcome. This is one of a series of episodes that Rick and I started to do last month, where Rick, who is Analysis.Tech's data guy, takes on in these episodes data topics, data management, data governance, data topics. And Rick, we're really thrilled with this series. It really is very, very helpful to people. This episode, Rick, we're going to be talking about whether or not it makes sense to copy data, especially the notion of copying of copying data because you want to access data only in place. This is, I guess, apparently a threat that you've seen being discussed recently, Rick.
Yes, indeed. Yeah, this is another one of those cases where I come across something I read on the prestigious internet that makes my blood boil. And this was something I read from a guy named Jeffrey Moore, who hopefully you know who that is. He's a brilliant man who's contributed an enormous amount of intellectual capital to our entire industry. And he was repeating something someone else wrote called the 12 Rules of Agentic Transformation. Like, oh, well, that is the sandbox in which we're all playing here at Analysis.Tech. I'd like to read those. So I started to read them. The first one called on unified data lineage. I said, this is great. I really like where this is going. I mean, not only is data number one, as we know it should be, but it's also unified lineage, which I like. And then I came to this second point, which is basically says you have to access data where it lives because of issues of latency and consistency. And it uses this as I said earlier, a rule. And first of all, when it comes to IT in general and data in particular, I hate rules because this is all dependent on getting to addressing a business need, getting to where you need to help us. So one size never fits all. But even more so, I think the thought that latency is better than copying, and you'll understand the air quotes by the time we're done here, than copying data. And there's basically four reasons why this is: performance, the freshness of the data, the correctness of the data, and the consistency of the data. Ostensibly, all of these are better if you reduce the latency as opposed to using a copy. And I would like to say I think this is actually not true. Two of
Mhm.
these are just completely wrong. One of them is usually wrong, and the other one is wrong sometimes. So let's go through them one
We'll
at a
walk
time.
through them, but Rick, I just want to highlight that this is a really important. This is in some ways is an old chestnut of a topic, right? I mean, we've been dealing with this for, as you like to say, decades. But on the other hand, it's way, way more consequential these days because there is so much emphasis on data access in the AI era applications. Data access, we're talking about data access on a scale that we just have not seen before. And so this is really a consequential topic, I think, even though it's been around for a long time. So walk us through. You want to start with the problem of consistency?
Well, let's start with performance, then we'll go to
Okay.
freshness, then we'll talk about correctness, then we get into consistency, which is a whole other realm.
Okay,
I
cool.
want to start out by saying everything I'm going to say from now on is not necessarily meaningful if you're doing the simplest type of data access you can do, which is accessing a single piece of data from a single data source. Okay. When you do that, you can do whatever you want. And unfortunately, many people who are developers, they think that's what data access is about. And I think if you kind of cross that line and get more data or get data from multiple sources, nothing changes. And this is why I refer to them as the dark side. everything changes, okay? And changes in ways which are very difficult to handle. And it's interesting you bring that up about the world we're in now. It's just stunning to me how people working with AI and working with data and AI have seemingly neglected everything which we've developed over the past 60 years. All the go fast tricks, all the consistency, all the really hard work that's been done. People go, I'll just put data in memories as bits. No, it isn't. But that's another topic for another day. But let's talk about those three things. The first is that performance will be better if you access data where it lives rather than make a copy. That's not necessarily wrong, you know, but if you are saying that that data lives in another cloud, on another server, in another country, accessing that data will not be faster. What I always say is accessing remote data will never be faster than accessing local data. It may not be slower, but it will never be faster. And keep in mind, especially if you're talking about worldwide data, data in different data centers, data around, it can be significantly slower. I mean, number one, there's the actual distance which you travel, and network performance and communication is not perfect. There's network partitioning. You have to resend stuff, okay? You could go from milliseconds to seconds. It happens all the time. So the idea that if you don't make a copy of your data, if you access your data where it lives, there'll be better performance. That's just not true. It will never be better. It may not be worse, but it will never be better. The second thing has to do with freshness of data. Will that data be fresher? Well, once again, it won't be fresher than the live data that you're working with locally because there's a time over transmission. Okay. And is it going to be fresh? And I think when people say is it going to be fresh, what they mean is it going to be correct or not? Will latency hurt the correctness of data? And the answer to this, as it is with so many performance things, is it depends. Okay. The issue is not how old the data is. The issue is whether the data is still correct. All right. The example I use for this is if you're doing a query or you want to find out how many states in the United States, you could have a latency of 65 years and get the same answer. Okay. So there's nothing saying stale is wrong. All right. And when we talk about consistency, actually, stale could be more consistent than fresh.
Hmm.
All right. And this gets us to the next topic, which is the correctness of the data. Because one thing I understand, and I really am happy about, people worry about is this data correct? And they say, and there's something to understand. Like I just talked about querying for the number of states in the United States. Is it wrong if there's more latency? Well, it's wrong if there's more latency if that data is changing a lot. Okay. If you have data, lookup data, stuff like that, it doesn't change that often. Okay. So it's not going to be wrong. Also, not going to be wrong if there's a copy made and the version you have in the copy is the same version that is in the database. And when we're talking about historical data, that is much more true than not true. Okay.
Hmm.
Typically, the data that changes is the fresh data, the stuff that's going on now. Once data gets to be weeks or months old, it doesn't change that much. But that's why we have databases, okay? Because you have lots and lots of data, not just what's going on in real time. And I know application developers and business people tend to focus on the new data, the most frequent data. That's not necessarily the bulk of the data you use or even the most important data.
Well,
So
particularly, Rick, particularly with many of the AI applications use cases that we have been coming across and discussing, there is always a part of the architecture devoted to business context. And mostly that's policies and things like that. That's exactly what you're saying. It doesn't change a lot,
no.
or it changes on schedules like Visa updating its rules and things like that. So,
And by the way, when Visa does that, there's a very explicit rollout to make sure that things remain consistent. Okay,
right,
it's not easy.
right. Hey, Rick, let's take a quick break. Guys, if you're listening in, watching, thank you. We appreciate your engagement with our podcast. If you want to engage with analysis.tech, you can reach us at sound the gong analysis.tech. We are an advisory firm, a strategy advisory firm. I'm one of the principals. Rick is one of the principals. Rick is our data guy. I'm one of the guys who coined the term low code. We also have our friend Rob Koplowitz, an expert on digital process automation, Dave Marcus, expert on DPA, also really deep experience in go to market strategy and partner strategy. Francis Carden, the godfather of RPA, is one of our principals. And lastly, we have with us the former chief economist of Forrester, Andy Bartels. So if you want to engage with us, we'd love to hear from you. If you like the content in our podcast, hit the like button, hit the share button. Please share with the community. It's a free resource to try to help the community advance. And with that, Rick, let's get back to our discussion. So did you leave off at consistency? I kind of lost track out of
Yes,
the four.
I left
So
off at consistency. So let's talk about consistency for some very broad brush, different types of use cases. All right. Once again, if you're accessing a single piece of data from a single data source, it will be consistent. Okay. You don't have to worry about it. It's always going to be fine. But as I said, almost never happens. Or if it does happen, it happens in prototype stage and not in production. It gets much worse in production. So then we're talking about what if you're getting multiple pieces of data from the same source? We'll start with that, the simplest use case. And this is not necessarily a problem. I mean, by the way, it is a problem, but it's a problem that databases have solved with 50 years of development time. Okay. Different locking schemes and different isolation level enforcement makes it so you get a consistent view of data going to the database. And friends, if those terms, locking schemes and data isolation, are things you've never heard of, you have some work to do, okay? Because this is what determines if your data is going to be correct. It is not simple. It's not simple for any data. And if you're talking about a database which is transactional with a lot of changes, it's really, really, really hard, okay? I have many stories to tell you about how hard it is, but trust me, it's really hard. But databases, advanced databases, Oracle, Postgres, some others, have things like multi-version reconsistency, which take care of this. But this basically has to do with, let's just be simple. You're just reading data. And you're starting reading data from row 1. And when we get to row 2000, is that data that you're reading in row 2000 in the same state that it was in when you read row 1? Or has it changed? If it's changed, it's inconsistent. That's called incorrect. All right? You want the freshest data? What is freshest a second after you begin your query is not consistent. So this is a real problem. It, if you're accessing, this is off a single data source, okay? If you're going out multiple data sources, now you have a bigger problem because you want a consistent view of data at the same time. So are these two different data sources using the same atomic clock? Okay. By the way, the answer is no. I mean, I've had conversations with companies who claim they can do distributed transactions, which you cannot do without a consistent time source, which is typically an atomic clock. I say, so what atomic clock are you using? They go, well, we don't use that. We don't need to. Yeah, you do. Okay. So if you don't have the exact, by the way, once again, it does not be the exact same time, but if the data is changing very much, and that's what we're talking about here, how to avoid, the data is changing very much, then you cannot say data from this source and this source are consistent, even if you get them at the same time. If you're talking about distributing, where one is here in Denver, and one is in San Francisco, and one's in Tokyo, and one's in London, you're in a world of pain. Okay, this is really hard to do. By the way to address this is to make a copy. The copy will be consistent because the copy isn't changing. And you can make a copy at approximately the same time, or sometimes exactly the same time. So when you're doing that, if you're copying all your data into the same place, it is consistent in that place. There are not moving parts moving at different speeds, creating inconsistencies. And once you do that, your problems are over in terms of consistency. Okay. So keep in mind, this is a big plus which you get from copying data that you don't get from accessing data in place. And when you access data in place, the more data sources, the more data, the greater the distance, the greater the problem becomes. And by the way, it's one which you cannot correct for other than say, we don't care if this data is exact. That, of course, is the definition of a slippery slope. Well, how wrong do you want it to be? Okay. I'm a data guy, all right? A data guy, if you look at data which is going to be correct 95% of the time, a developer says, that's pretty good. A data guy goes, that's terrible. I expect that means all the data is wrong. So, anyways, that's a problem that you have. But it is actually even worse than that. This is typical data guy stuff. Oh, yes, it's actually worse. And that comes in with this idea of accessing data in place when you're using different use cases, because data is treated differently in different use cases. There are different rules for making sure that data is correct. I call that data governance. All right. And if you have two different use cases accessing the same data, or let's be more exact, data sourced from the same place, they may have different governance rules. Okay. If you are going to access this data in place where it lives and treat it as a single unitary source of data, the adjustments you have to make sure that data is properly governed have to be done on the fly. And by the way, have to be maintained and coordinated from a centralized location. Because if the governance rules change here and they don't change here, you got to make sure it all works out properly. And frankly, some of these data governance rules are not simple. They're fairly time consuming. So therefore, you're going to have a hit on performance. All right. It's much easier when you copy things over to do that governance work as part of the copying process. All right. And I use the word copy. I should use the word copy because, in fact, if you're bringing it over to another physical location and you're giving different governance rules, you're changing the data. It's not a copy anymore. It's a version sourced from the same data. Okay. This is not a grammatical nuance. This is a dramatic difference in whether the data is correct or not. So I
Right.
guess in talking through this, and you probably can expect, I've come to the point where I think, there's nothing wrong with copies or rather versions of data. In fact, they solve some really hard problems and they make a whole lot of stuff easier for you. You don't have to worry about that stuff anymore. If not, you do. So to come up with a single rule that says to access things in place for reduced latency is not nuanced, usually wrong, and actually always wrong. Well, frequently wrong in many ways, which are very important, having to do with the correctness of.
Well, you said I loved your comment initially, Rick, that having hard and fast rules is really foolhardy. And I think you've done a great job in laying out the dimensions of the issue, that the dimensions of this issue that you as a developer, have to think about. There's what is the nature of the data? How often does it change? Distances and their effect on performance. How are you going to rationalize data coming from multiple sources, multiple different sources? Because that's the nature of the beast in process automation and AI. So it's like it sounds like you've got to have a data architecture approach, a strategy, given the use case that you're tackling, and that's gonna be different depending on all of those factors. Is that
I
right?
I'd go a little farther. I'd say if you want to have a topmost rule, I'd say it would be practice good data hygiene. Okay. And by that I
What do
mean
you mean by that?
consider
Yeah.
the use case, consider what you need your data to do, and make sure it's there. And one thing I would like to say, kind of a little bit contrary to what you said, John, Mr. Developer, you don't have to worry about this. That's what data guys are for. Okay. But you have to coordinate with them and you can't take it for granted that things are working the way you assume they're working. Okay. Because, look, I worked at Gartner for 10 years. So many of the problems we have are all due to the same thing, which is a communication gap between developers and data people, between developers and end users, between end users and corporate. When you have a CEO saying, I want a single source of data, I want a single copy of all our data, like, are you wrong? You know, but If they would just talk and communicate, they'd understand, oh, this here's an exception, here's an exception, here's an exception. Maybe we should look at this rule in a different way, since it seems to be more exceptions than rule at this point.
Right.
So just you can't ignore that stuff, and you can't assume that it will be taken care of. Like I said, database management systems have been working on this for decades. They're really good at doing this, but at the same time, you have to let the data people know what you're looking for, why it's important, and what governance should consist of because of it.
Brilliant. Hey, to close, Rick, I'm going to put you on the spot a little bit. You told me about a conversation you had with the person at a recent conference who had come into software, who come into application development from a business background, and you asked her when you start. Well, you tell the story. I'm not going to
Yeah,
tell the story,
this is
but you
at
know what I'm talking about.
a conference for a vendor that does a lot of end user development, that does a lot of low code development. And they had this woman speaking. It was a really great story. She started out as more or less in a more or less administrative role and started developing stuff. And she ended up being in charge of development of a whole suite of applications, mission critical for use by the organization. And one of the questions they asked all the people, all the customers who were on stage, was, "What is the one thing you wish you knew?" And she said, "I wish I would have known how important data was." And I went up and talked to her afterwards. She said, "Yeah, I just didn't think about it." And later I realized, oh God, we screwed up. We should have been doing that from the very beginning. I mean, data's the foundation you build on. And the thing I just really, if I can scare you with one thing, let me scare you with this, okay? It's when you lose data integrity, data correctness, you cannot get it back. Okay. Trust me on this. Well, we'll have a compensating transaction. Well, what if someone else changed it between the time you ran the first transaction, the time you ran the second? And the thing about it is, it will be. I once wrote a blog, and I was very proud of myself for using the term SBD to describe loss of data integrity, silent but deadly, typically used for another human phenomenon. But it's one of these things I can almost guarantee you, when you find out it happens, it will be too late. Okay.
All right, Rick,
And
thank you. Words to the wise. Spend the time up front on the data architecture, on the governance, etc. Rick, thank you very much. Folks, thanks for joining. If you're still with us at this stage of the podcast, thank you very much for joining and listening in. Rick's research is available at analysis.tech/research, and Rick is available to help. Again, you can reach him at analysis.tech. Thank you, and we'll see you the next time on The Lowdown by analysis.tech.